welcome to Haseeb Electronics. Friends, today we are going to discuss about DC inverter air conditioner inverter control board. We will discuss in blog and we will correlate this board step by step. First of all, we will discuss compressor. Inverter compressor, it have, instead of a normal compressor, it have 3 windings. 1, 2, 3. We can say star winding, delta winding, anything. Every winding it is 3 phase. Just only we have to understand this. Normal compressor, it have starter winding, running winding, and we know it takes too much starting current, a normal compressor. But DC inverter AC, this is actual variable frequency drive. Its motor pulse DC voltage but 3 phase. These voltage are controlled by any inverter section, any frequency drive. What is in frequency drive? MOSFET, IGBT, anything. MOSFET, IGBT, most of the time there is IGBT used. It is in general discussion. And frequency of this always produced by some microcontroller or anything. Sometime it is standalone processor, sometime it is microcontroller, sometime it is motor control, intelligent motor control, different items. It depends upon the designer how he is using. The MCU will need power. What power? VCC. This drive circuit also need VCC. To generate VCC, we need SMPS. What kind of power it will generate? It depends upon MCU. If it is 5 volt operated, we will set 5 volt. If it is 3.3 volt, 3.3 volt. In between this, there is IGBT driver. So to apply VCC, we need some voltage here. Some IGBT drivers are 6 volt operated, 8 volt. Some of them are 18 volts. Here we will receive variable voltage, variable frequency. In normal compressor, we just apply 220 volt to the compressor, it starts running. But here, to increase, to control the RPM, we have to change the frequency and voltage. How it will generate a voltage? We need a rectifier circuit, plus PFC circuit, power factor controller. This rectifier will take 220 volt, single phase, line and neutral. So it will generate, it will apply 220 volt. This circuit will convert it low voltage for MCU to VCC, frequency drive. Even if here is microcontroller processor, because we are using it in air conditioner, so it have to, if we are using in refrigerator, it will the same. If we are using in air conditioner, it will sense room temperature, exhaust temperature. Sometime it will check pressure. If there is a stuck in any line or anything, then it can check the compressor temperature, oil temperature we can say, and then it will perform different functions. Power on command is injected here because it is software controlled. Instructions are given to this microcontroller. If room temperature is this, you have to turn on compressor at this speed. Maybe it is taking command from indoor board, indoor unit control board. When everything is here, then maybe it will give a feedback to indoor unit to display, and it will monitor the circuit here. Then it will generate a feedback command. If there is error, it will generate error. It will need to run a cooling fan. Sometime it has relay. It will connect 220 directly to this. If it is IGBT mode, DC, if it have DC motor, then we have IGBT drive. Then we will apply this 330 volt and this processor will also drive the same set here, and it will run the cooling fan. If it is hot and cool, then it will make a drive to relay or switch to change hot and cold. So let's start, and we will see this block diagram and we will correlate in this board. If we are using any type of DC inverter AC, the design may be different. Here it is using 3 capacitor, maybe there is 2 capacitor or 1 capacitor. Here is IGBT in intelligent mode in one chip. Maybe in some air conditioner you will find 6 IGBT modules here. It has 6 modules, but it is built in one chip. Here is also IGBT. I removed it. That is for power factor correction. That was short circuit. And the neutral is in here. If you go in back side, line is connected to one fuse. The line is connected to one fuse. Line to fuse. In the second side, a fuse, there is over voltage protection. After that, one capacitor, line inductor, dual line filter. Here is our neutral line. Neutral is in this area, and at the same time neutral is connected to this terminal. We will discuss this terminal later. Now it have to pass from this inductor, and then we receive neutral here. This neutral line is going to this point. Just only we have one component in this line. From neutral, this point to this point, we have just only one component, that is inductor. Series. In series we have just one component. So here we have capacitor, inductor, line is here. This line will reach at this point. This is line will reach in this point. We will discuss what is here. And now line is in this area. Now line will pass from this fuse, inductor. Now line is here. So our current will pass from this inductor. This current will pass from this inductor. So our current stopped here. Now we have to see here. It stopped at this component, this black component. It is called PTC. In normal condition, its resistance is 36 ohm. Then our positive line from this PTC will reach here. What is that? That is an other inductor. Now we got AC 220 volt, started from here and reached here. What is here? Here is a bridge rectifier. Bridge rectifier. Now very interesting story is going to start here. AC, AC. Here it is giving positive, here is giving negative. This end is positive, this end is negative. The negative line is connected through a jumper resistor, through a power resistor. It is working as a fuse resistor in case of any short circuit, any over temperature, sorry, not over temperature, any overcurrent condition. There is a resistor inside. It is jumper resistor, two resistors, 1 and 2. We will see one by one what is their function. This end of the bridge rectifier is negative terminal, and this voltage reached at this IGBT. Here is IGBT. We will discuss why this component is here and what's its function. Now the voltage will pass from this resistor and we will get this voltage at 1, 2, 3 capacitors. This terminal needs, one end of every capacitor needs negative, the second should be positive, so we have to see the positive. For positive terminal, if we look at the bridge, this cut mark, this end is angle and here is a cut. This 90 degree angle, and here is a cut. So cut mark is positive, so we have to see the positive. So here it is positive. So positive line is starting here, this dotted line, and positive line stopped here. So we have to see what is there. Here is written a reactor. Reactor. What is reactor? Reactor is a piece of coil. It is in transformer shaped. It is about 16 ampere. The wire can take. It is very big gauge, so it will reactor. It is big size, about 3 inch by 3 inch by 3 inch, and it have just only one wire inside. That is in core. And now we have to see the board condition. If we look here, I hope so we can look it clearly. So here it is reactor. So reactor one end is connected here, the second end is connected here. Here is reactor. So reactor is connected between capacitor positive terminal and this point, between these 2 points, this point and this point. So we will take, we can say it is working as a jumper, but it is not a jumper. It have a very special function, very special feature. We have to see it. So from here to here we have reactor. If you look here, it is connected to this point. So reactor is connected from this point to this point, from here to here, and other thing. So reactor reached at the collector. It reached at the collector of IGBT, and now so our voltage reached at this point, and then there is a diode, power rectifier, Schottky power rectifier here, that is forward bias diode. So we will receive these voltage at rectifier, and this rectifier the cathode side of this power, it is transistor shaped, it is IGBT shaped, but it is not IGBT, it is power rectifier, it is high current rectifier. So in the output of this rectifier we have 1, 2, 3. We have 3 capacitors in parallel. Now we will discuss the function of these 2 components, IGBT, reactor and rectifier. So we have to do some correction. This line, this pin of IGBT is connected to ground line. This pin of IGBT is connected to ground line. So this pin is IGBT base, IGBT drive pin. We will discuss function of this IGBT reactor and rectifier. We have positive 300 volt, and we said these are passing through this rectifier. So these voltage are going to one capacitor, second capacitor, third capacitor, and these capacitors are in parallel. And here we have one reactor, 330 volt here, and here we said at this point we have a rectifier, sorry, IGBT. We say we are taking 300 volts. When there is no signal at the base, there is no drive pulse, it will do nothing. The voltage coming from bridge rectifier will pass directly to these capacitors. Now because the compressor and drive, fan motors and everything takes too much load, and it will cause to decrease the voltage level here, or maybe the input that is not 220 volt, that is, we can say 180 volt. If 180, at that time these voltage will go to 280 volt, suppose, because the same time the voltage will drop, input voltage multiplied by 1.414, that voltage level will here. So at that time this IGBT is working as a voltage booster. It will take pulses. The first function, it will regulate the voltage, it will make power factor correction. The second function of this device, to adjust the voltage in running mode. Why? It have to adjust the voltage and make power factor correction. When it will make a switching, what will cause? it will cause to induced voltage, induced magnetic field is in this inductor. When the pulse will off, this magnetic field will collapse. When it will collapse, it will induce voltage in the coil, again this inductor. So this reactor will generate a voltage in series of the voltage coming from the bridge rectifier, and this pulse will be rectified and it will compensate the loading effect. The processor will send pulses, and these pulses will cause to make a parallel path, because here we have positive and negative, and it will make a surge. When it will make a surge in parallel, because here is load, it is in parallel surge, so it will cause to induce magnetic field. When the pulse is off, this magnetic field will induce voltage, counter EMF, reverse EMF in this reactor. So this reactor will boost the voltage level, and that voltage level, that pulses will rectified, and we will take maintained or regulated voltage level at these capacitors. For ripple removing small capacitors, these are used to remove the noise. I am not going to discuss the noises and everything. We can say 300 volt regulated here. In standby mode, these voltage will 290 volt to 330 volts, but in inverter mode, it will, in running mode, it will adjust the voltage from 210 volt to 300 volt, and 300 volt we will get here. Now we have to discuss something very special. We received voltage at these capacitors. Now what will happen? Here is a power link at this point, connector number 14, that is P, connector number 14 P, and it is connected to connector number 15P. So this line is coming here. We have to install jumper, that's a short link from here to here. So positive voltage will applied here at this IGBT module. This positive pin of this IGBT, this pin is positive. The negative side of this line is connected to this resistor. So negative line here, this resistor is giving voltage to this IGBT module. So black line is here at this point, and this end is ground line, and positive voltage, these positive voltage will jump from this connector, here is positive connector, to here. So here is positive line. Positive voltage. Here negative, here positive. What is here? Here is SCM 1240, high voltage, high current, 3-phase motor driver. This is intelligent module. If you have 6 IGBTs here in one package, the same 6 IGBT are here. 1, 2, 3, 4, 5, 6. Because it is intelligent, it have to monitor the currents and everything, it have to check everything. It have half bridge circuit, consists of pre-driver circuit, 10 ampere to 30 ampere output of small footprint, 10 ampere to 30 ampere. So it is high power, high current, CMOS compatible input and different things. We are not going in too much detail, just only I am sharing the data sheet. So we have to see here the inputs are applied. High and low and common. High input H in for every phase. High input, low input, common. Phase 1, high input, low input, common. Phase 3, high input, low input, common. PO3, PO2, PO3, everything is here. So it needs a controller that will generate high frequency or variable frequency, and it will drive through a line driver, and it will give the voltage, switching voltage to these pins, high drive, low drive. So here it have built-in high FET, low FET. At 31 pin it takes positive voltage, and at this pin it receives negative voltage. The capacitors, as we discussed, there is a one resistor, series resistor, and it will apply voltage to every low side MOSFET. Low side IGBT, low side. So every low side IGBT will take voltage, ground voltage from here, and pin number 31 will have positive voltage. So here is pin number 31. It is taking positive voltage from here, which we discussed that a jumper is installed from this point to this point. So we will apply a jumper and we will check. The ground line is here at this pin, and if you look here we have 3 ICs for every phase. Every phase it have high and low driver. 1, 2, 3. So high and low drive from this IC for this phase, and this IC for this phase, and this IC for this phase. So we have 1, 2, 3 ICs, and at the same time portion of this drive is also driving the IGBT. When it have to regulate the voltage, the IGBT drive pin, this pin, will take command from this resistor. Here is a SMD resistor inside. So this SMD resistor will take command through processor. From where the commands are coming, I will show you. Yes, all the commands are coming from here. We discussed we have a frequency drive. What is frequency drive? That is this IC. This IC is frequency drive. It is a switcher stage. Switching stage working. Functional block diagram is here. It is SCM1240M. This IC. So, and we have driver stage. The driver stage is here. These small ICs, IR driver ICs, 1, 2, 3. It takes VCC to drive this driver section. 1, 2, 3. We need MCU, microcontroller. This microcontroller IR MCK311, it is 8051 based. It have 8051 processor. When we use, it is complete motor drive, 3-phase motor drive, 3-phase generator. This IC, this small chip, it is complete processor. It is used to generate signals for 3-phase motors for switching. These all drives here are going to these ICs. From here it is given because these tracks are very small, so we are giving commands. It is generating commands from here. Yes, it's more visible from here. So it is generating commands to these ICs. Here it have serial EEPROM, because this chip, it needs source code K311. It is using serial EEPROM. It is using serial EEPROM plus EEPROM, that is memory, that is 2-wire serial EEPROM, that is 24LC08. What is that? That is 8-pin IC, serial pin IC. And here it is facility to connect with the computer. If we want read, write program, it is directly communicating here with this one. And then it have its test connector here. If we send data and read back data after processing, so computer will connect it here. 311 test connector. So this test connector will communicate with this one. It have its own clock generator, so it will generate clock and it will read the data. And when it have to turn on, how it will work? It will accept the commands from this computer, from this processor. When processor will find everything is correct, input voltage are correct, room temperature is low, exhaust temperature is within limit, the compressor temperature is good at that time, and we need to cool down the temperature, and we want to turn on the processor, at which rate the processor will define, and it will send a command to this processor to adjust the frequency, slow running, fast running. So it will generate, it will make a sequence between the phases, and we will receive its command signals, every phase, high and low drive. We have 3 phases, so it will generate 6 lines, and it will ensure the phase combination at exact sequence. So everything will flow in this way, and our compressor is connected between these 3 terminals. Blue, that's called UVW. Blue wire is here, red wire is here, and black wire is here, W. When we need to power it on, because this is power stage. As we discussed, to power it on and to power this system, we need a SMPS, switch mode power supply. So switch mode power supply section is here. This is this small transformer, voltage regulators, LM317, 117, 217, adjustable voltage regulators for these chips. First, it will take 300 volt from main capacitor through this resistor, and it will, here it is power controller, SMPS controller. So SMPS controller will apply voltage, generate 2 voltage here, 2 types. This SMPS transformer, this SMPS circuit will generate 17 volt approximately and 12 volt, and these voltage are regulated in 5 volt and 12 volt. Further, these voltage are regulated for 3.3 volt from here, and we will get these voltage on these capacitors. So our power supply, this standard alone power supply will generate plus 15 volt plus 12 volt and other power supplies whatsoever. So first of all we have to check if the board is not working. We have to check the voltage at these points. Ground 15 volt, ground 5 volt. If you don't have voltage here, here is 3.3 volt, sorry, 3.3 volt regulator is here, and we will find these 3.3 volt from here, from this point. Here is 1.8 volt, 1.8 volt and 3.3 volt. All voltage are mentioned on this board. So these power supplies are necessary. Here we must have 15 volt after regulation. If the regulator is working good, this regulator is good, we have to find 15 volt. And then we must find 5 volt here at this point. This 5 volt, 15 volt, 3.3 volt, 1.8 volt. 1.8, 1.8, 3.3. If these voltage are available, then this work and these chips will start working. Now, we discussed SMPS 3.3 volt, 1.8 volt. So these voltage must be available. I will not go in very detail how it is working. So just only we have to check if any power supply is not good. We have to ensure proper functioning of the SMPS. Then move to this area. Now, as we discussed, when we turn on the compressor will run. It will generate heat, and we have to turn on the blower. For cooling this we need cooling fan. So here is another, sorry, this number I written wrong. It is SCM 1240M. This IC, I am sorry for mistake. Then we have here another IGBT driver. What is there? It is here. Its function is approximately the same. It is low current, 3 ampere. It have 3 phases, 1, 2, 3. The same, it takes voltage, the positive voltage from here, and it takes ground. So it will generate 3 phases for our blower motor, this one. So it is using STK 5C4U332. It is the same this IC, same this IGBT module, and it's also intelligent power module. So it will take, similar to that one, it will take command from the controller, and it have the same drive, 1, 2, 3. These are outputs, and it have positive side and low side, neutral and positive side, V positive and neutral. And here it takes high side drive 1, high side drive 2. It is its controller. The controller is inside. The sequence controller is inside, and it will take high input 1, low input 1, high input 2, low input 2, high input 1, high input 3, low input 3. So all inputs will fed to here, and it will sample pre-amplifier and it amplify, and then we will take the final output from these points, 1, 2, 3. So 3 phases because it is also speed controlled for energy saving. So here is DC fan. Now our this portion cleared. In this board we have another microcontroller. This MCU, it is motor controller. This MCU for motor control, for checking these inputs, checking all these parameters and communicating with indoor unit, performing other functions. We have another microcontroller here. Here is another processor. These all parameters are controlled by NCE processor, that is D79F8513A, and this processor also using 24LC08 EEPROM. This EEPROM, and this is processor. This processor will monitor all the requirements and it will control all the functions of this board. Where is that processor? That processor is here. Here it is programming clip, self-test pins, this connector and this connector. This programming clip for connecting with this EEPROM to test the function of this processor. These are the test connectors, and exhaust temperature, room temperature, all sense lines are connected to this processor. What is the room temperature? It will sense the room temperature and it will communicate with this IC, and this IC will start the compressor. If the temperature is increasing, it will spin up the blower motor. And the meanwhile, here it have ULN2003. It is ULN2003, that is transistor array, Darlington transistor array, that is used to switch different devices. ULN2003, it takes command from the processor, then it connects ground with out number 1. Every line is, we can say Darlington amplifier. It is working as a switch. So all the inputs are connected to output. If I need to operate a relay, suppose plus 5 volt or plus 12 volt, what will happen? This pin I connected to ground. When I will give a signal here at input number 1, processor signal, because processor cannot drive a relay, so it is working as an amplifier. So it will switch pin number 1, it will apply ground to this pin and relay will activate and we will take some necessary function from this one. Here is ULN003. If we see, this track is output side and this track is connected to this relay. The same time there is one other track that is hidden here. This pin will connect to this relay. These are relays. What is the function of these relays? These control the four-way valve. Four-way valve is connected here at these 2 points. So these 2 points, from this line, we told, if this relay will operate, it will rotate the solenoid, four-way valve solenoid. And at the same time, if the compressor temperature, internal temperature is down, at that time this processor will give command to this relay and it will connect 220 volt to compressor heater. So it will heat up the compressor to build the proper pressure of the gas. For proper compression, we need 220 volt to connect with the compressor heater. When the temperature will maintain, it will disconnect a command and it will turn off. DC fan reactor. This is earthing line. Here is our, this connector is a reserve spare for more modifications. So here are, I hope so, here we have optocouplers for feedback 1 2 3 4 to connect different sensors and different inputs. Here another reserve connector. It is for 12 volt pulsed PMV. Friends, if this video is good for you, if it is helpful for you to understand the function, just remember me in your prayers, because this time it was this board was under repair. This board does not have the SMPS IC, so many components are removed. IGBT is missing. So we can take a look on this board how it is powering up, but we don't have SMPS this time, so I cannot power it on, because when I will apply power we must have VCC and these power supplies. I hope so. If I bypassed this power supply, then I will try to power it on here, and then it will very helpful to understand the function of this board. So friends, as I discussed, this circuit does not have PWM controller because its PWM IC is burnout and it has some problem in this area. Optocoupler is missing. So what I did to show you the function, I bypassed this SMPS. This SMPS external power supply, this is for satellite receiver. I connected this power supply and I will show you the connection. When it is connected, we make a jumper, this positive voltage to this IGBT module, and from this point to this point there is a reactor, from this point to this point, and we need IGBT, but IGBT we don't have. So this time, because I am not going to run the compressor, so without IGBT we will turn on this module. I will connect jumper. I connected jumper from in place of the reactor, so we will directly take 300 plus volt at these capacitors. Okay, and how I could connected this power supply, it have no isolation, so never take a risk. If you don't have a good experience in electronics, never do this practice. I got 22 volts from this power supply and 12 volt to this power supply, as this SMPS gives us 12 volt and 15 volt at this point. 12 volt is regulated into 5 volt and 17 volt is regulated into 15 volt. So I connected 22 volt here instead of 17. Now I will connect power, because this external power, this will take 220 volt, and I made common ground for the board with both power supplies. Now at this point we must find AC voltage. Set multimeter to AC. At these points, input terminal, I am taking 231 volts. After passing this complete circuit, at the input of bridge rectifier, we will find 321 volt. output of that is 330 volts, and this 330 volt I made a jumper from this point to this point, and this voltage from this point to this resistor, jumper resistor, we will take this voltage here, 329 volts. If this 329 volt is not available, that means our bridge may be problem, bridge rectifier problem, PTC problem, fuse have some issue. So this line must be in this shape. So we should find voltage in this way. When these voltage are available, same time these voltage must be available at the bridge, this module, 332 volt. If we have this IGBT module here at this point, this IGBT will regulate it at 300 volts when it will power on. So in this point we must take 5 volts, here 12 volt, but this time as I have external 12 volt, this 12 volt, okay, and we should find this 3.3 volts must be available at this capacitor. This 3.3 volt for processor, 1.8 volt it is available. This voltage 1.8 volt for EEPROM. If we don't have this voltage, that time our circuit will not work. 15 volt available. So when all power supplies are okay, this circuit must work. But this time it have some optocouplers missing, so we powered on. I bypassed this external power supply. So I hope so this video is good for you, because this time we did not connected the sensors and everything, and we cannot complete the test. Moreover, I told you for the power supplies how it is working. So thanks for watching. If you want to subscribe, it is up to you. If you want to like, it's up to you. Thanks for watching. And if this video is some informative for you, you can share with your friends. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.